In the previous lesson, we measured the relationship between two different variables, such as GDP growth and inflation. Today, we ask a different question. Instead of comparing two variables, suppose we observe only one variable over time. Can today's GDP growth be related to yesterday's GDP growth? Can this year's inflation depend on last year's inflation? Can today's unemployment rate be influenced by last month's unemployment rate? In economics, the answer is often yes. Many macroeconomic variables evolve gradually rather than changing abruptly. This persistence gives rise to one of the most important concepts in time series econometrics. Autocorrelation, also known as serial correlation. Economic activity has momentum. Factories do not suddenly double production overnight. Households usually adjust consumption gradually. Inflation tends to remain close to its previous value. Interest rates often change in small steps rather than large jumps. Consequently, today's observation usually contains information about yesterday's observation.
To understand autocorrelation, let us simulate the annual GDP growth rate of an imaginary economy over 20 years. Instead of generating completely random numbers, we shall make each year's GDP depend partly on the previous year's GDP. This creates persistence, which is exactly what autocorrelation measures. Notice the pattern. The GDP growth rate changes gradually. Large jumps are uncommon. Each observation resembles its predecessor. That is the hallmark of autocorrelation. The line graph appears smooth rather than erratic. Neighboring observations tend to move together. This visual evidence suggests positive autocorrelation. But visual inspection alone is not enough. We need a numerical measure.
To appreciate autocorrelation, compare the previous GDP series with a purely random series. A random series has no memory. Every observation is generated independently. Consequently, successive observations fluctuate unpredictably. The difference is immediately apparent. The persistent series moves smoothly over time. The random series oscillates sharply from one observation to the next. Persistence indicates positive autocorrelation. Random fluctuations suggest little or no autocorrelation. Autocorrelation measures the relationship between a variable and its own past values. Instead of asking, how are GDP and inflation related? We ask, how is today's GDP related to yesterday's GDP? The stronger this relationship, the stronger the autocorrelation. In this lesson, we introduced the idea of autocorrelation. Unlike ordinary correlation, autocorrelation measures the relationship between a variable and its own past observations. Using simulated GDP growth data, we saw how persistence produces smooth movements over time. We also compared a persistent series with a purely random series and observed the visual differences between them. In the next part, we shall derive the sample autocorrelation coefficient, understand its mathematical formula, and compute it step by step using Mathematica.